What's going on, guys? So today's video is going to be kind of a follow-up topic to a video that I made a while back where I talked about the difference in how RVs are constructed, engineered, designed compared to the automobile and truck industry. Because oftentimes I think people more correlate an RV to a vehicle versus a home. And I know it's recreational vehicle, but that's simply because it's a towable device or a drivable device that goes down the road. But that's mainly from a trailer or chassis perspective. Whenever you start talking about the rest of the structure, that's where things really take a different turn. And construction changes from vehicle type construction to residential type construction. So let's talk a little bit more about that. And I think this is going to be a topic that's going to be interesting to follow just because of the differences that you may know about, but some of the differences you may not know about. So hang tight, I'll be right back. Okay, so the differences you know about are the fact that, most RVs are constructed of about 90% wood and lumber. It's not necessarily like a vehicle where they're made predominantly of steel, aluminum, and plastics. Whenever you talk about an RV, you have really two components that make up the majority of the RV. The first component, or the first major piece of equipment in an RV, is going to be the chassis. That's generally going to be steel for most manufacturers. There are a few that use alternative materials like aluminum, but in most cases it will be steel, and that will be your chassis, your running gear, your axles, your springs, all of that. And then you're going to have the box. The box is what sits on top of the trailer. Think of it this way. You could have a gooseneck style trailer, basically what you see hotshot drivers pulling down the road, where it's essentially a steel chassis with maybe wood slats or steel plating on the bottom. And that's essentially what an RV is, right? That's what the chassis of an RV is generally designed as. And then you have the box that goes on top of it, which is your residential structure. There are a few reasons why whenever you look at how both are designed, they have to be designed separately to accomplish two separate tasks, but then at the same time, they need to work in conjunction with each other, such as holding tank placement, where you're going to run your electrical, where you're going to put your slide outs, all of those. It all matters. Now, when you're talking about the box, basically the residential living space that's above the chassis, the box itself has to be designed and engineered to meet several criteria. One of those criteria is limited weight. So what you don't want to have happen is you build this structure that goes up, and you build it in such a way that it creates imbalance, and it can also create instability, such as moving your center of gravity too high. Right? Therefore, if you run into heavy winds, if you are having to make an aggressive maneuver, anything like that, if it's too top heavy, well, it definitely increases the likelihood that it will roll over or that it could flip on you. And I don't think anybody wants to experience that. So as an RV gets taller, or as you move up the box, they want it to be lighter. They don't want the weight to be centered around the top. Ideally, manufacturers want the weight to be centered in and around the axles as well as the front of the RV, just so you can handle the pin weight or tongue weight depending on what type of unit it is. And it makes it even more complex when you deal with toy haulers, because of course you're figuring into the equation that you're going to have something heavy in the back. So you have to counteract that somewhere, and you have to put enough weight up front to be able to offset the weight that you put in the back, so you don't, again, have instability. So whenever we look at the engineering that goes into an RV versus a car, there's absolutely engineering, but there's different types of engineering because there's different requirements. So when you look at a vehicle, there are a lot of different areas where fit and finish have to work well. For instance, if you have the door adjusted 2 millimeters off, it's not going to close properly on a vehicle. If you have the sunroof 2 millimeters off, it will likely leak. If you don't have the right type of suspension on that specific vehicle, well, it's going to be a jarring ride on the inside because you ride on the inside of a vehicle, whereas on a travel trailer or fifth wheel, you don't. There are other considerations, such as how do you secure items that have seatbelts attached to them. So for instance, If I'm sitting in a seat, my seat needs to be able to withstand a collision and not come detached from the vehicle. Well, that's not really a consideration in an RV. If you're in a major collision, the screws and nails and things that are holding some things in place in your RV could very well become detached. There's nobody's life that's on the line inside of the RV that is sitting in a chair that could potentially become detached. Now, if you are in a motorized RV, then yeah, that changes. You need to have seating that's designed to be able to withstand impacts and be able to keep people in their seat and secure in the event of some type of a collision. When you look at how an RV is engineered, typically the engineering of an RV is going to be very similar to the engineering of a home, except for the chassis portion. Now, here's where things take a very dramatic change. When you look at automobiles, they generally have hundreds of engineers that are assigned to designing, developing, and building each vehicle, regardless of whether it's a cheap car all the way up to a very expensive truck or luxury sedan. Hundreds of engineers. And they work with teams that have to essentially master a specific area of that vehicle, such as the powertrain or the chassis or the frame or dynamics in relation to how it rides and, engine noise. All these different things have teams of people that get together and that are typically led by a head engineer as well as several other engineers to make sure that everything works out well. That's why the typical production cost or development cost of a new vehicle can be well over $1 billion. When you look at the RV industry, on the other hand, you have engineers, but you don't have the same type of engineers because a lot of the things that matter in vehicles don't matter in travel trailers and fifth wheels, such as engine noise. Well, you're not going to have that as a problem. So that's a huge area that doesn't need to be addressed by an engineer. You're going to have structure, you're going to have rigidity, you're going to have chassis, all of those things. And there are engineers who deal with that, but the engineers may not all be at one place. So let me give you an idea of what I'm talking about. The frame itself is typically manufactured by LCI, or Lippert Components. Lippert has engineers that design the frames, and the frames are designed to spec for each manufacturer of the RV. There's not just one universal frame that goes out to everybody. So when you see RV manufacturers that claim they have a specially designed Lippert frame, well, that's more of a marketing thing than anything, because anytime you come up with a new floor plan, the frame needs to be designed for that floor plan. There may be a stockpile of certain types of frames, but most of the time there's going to have to be some modification. There's going to have to be something done. And then an engineer at LCI is going to have to approve of that design, because the last thing they want is to be held liable because a high percentage of frames come back with some type of an issue. So that's what you have to keep in mind there. LCI has their engineers that manage their process. Now, when you look at vehicles, there are frame and chassis engineers, there are suspension engineers, but they're all typically part of the manufacturer. They're part of that same organization. Whereas the RV industry is very much a components industry, where the manufacturers of RVs reach out to a component manufacturer and say, we need this component made for us, we'll buy it from you so we can assemble an RV. Now, there are other areas in an RV that do require engineering, but typically not so much engineering that you need to have a team of engineers. It's usually what has been changed in a specific type of floor plan or a specific type of model that requires the engineering aspect to be reevaluated. Similar to horse trailers, similar to cargo trailers, gooseneck trailers, and other types of trailers that are not motorized, you have engineers that are involved. And most of the time, there's a head engineer that understands the dynamics of how trailers need to operate, where things need to be, how you need to design it from a rigidity and structural support perspective. And they are involved in every aspect of designing a new floor plan or making some type of major modification, such as when a manufacturer wants to do an elevated floor system, or they want to do, some type of a unique kitchen setup where it adds a tremendous amount of weight to a different area of the RV. But you also have to remember, when you're talking about RV floor plans, one manufacturer may have 6 to 8 different floor plans, Whereas in the automotive industry, you might have one manufacturer with teams of vehicles across multiple different brands. So you're going to have more engineers that don't collaborate across different makes and models in the automotive industry because there are so many makes and models. For instance, of course, General Motors has a GMC truck division, they have a light truck division, they have a commercial truck division, they have SUVs, they have all sorts of different vehicles. And the engineering teams are typically set up by the type of vehicle that they're working on at that moment. And in many cases, they shift around and move to different groups so they can essentially be cross-trained and they can get experience in other areas. I know when I was doing some of the Ram events, some of the folks that were there came from the Jeep side, or some of them came from the Chrysler side, or they came from different areas, and they're now focused on a certain specific area of a new truck model that they're coming out with because maybe they excelled really well at suspension dynamics on, you know, their Chrysler 300, and they wanted to bring some of that innovation to the truck side. So there are those cross collaborations that take place. In the RV industry, it's not so much needed. Now, the one area that I believe the RV industry does struggle with, it's final fit and finish and inspection. And I also believe another area that the RV industry could definitely do better in is finding ways to make things less interfere with other things. So for instance, when you see wiring and such, I mean, I think almost anybody knows if you pull the panel back where all your controls are in an RV, it's going to look like a jumbled mess of spaghetti. And even though it may not pose a fire risk or it may not pose some type of major issue under ideal circumstances, there are always the occasional issues where something could happen. And if you simply changed maybe the type of connector you used, or how you routed the wires, or what you used to route the wires, maybe if you added more fuse blocks in, maybe if you added more, you know, bus bars, things that could isolate and move wires so they're not running across each other or near sharp objects. Those things I don't believe would add a tremendous amount of cost, but they would also remove a huge risk that you could potentially have some type of an issue later. So I think that's the area where you need to see more engineered focus. You need to see engineers coming in to say, how do we make the wiring aspect of an RV better? How do we use better parts? How do we use insulated parts? How do we use parts that have a lower likelihood of just failing under normal use? That's the area that I really think manufacturers should focus on. But here's a surprise for you. A lot of component manufacturers actually make those parts. So a lot of component manufacturers like Lippert, like Moride, you know, there are a ton of them out there that make upgraded suspension components. They make upgraded shackle components. They make upgraded electrical components. They have some really nice control boards with like One Control as well as ASA in command. They have ways so you can clean up a lot of the wiring and it doesn't go to this jumbled switch box. But the problem you then deal with is how much incremental cost does it add to the price of the RV? How much complexity does it add to a unit where sometimes people just want to get in and hit a button? They don't want to go through a touch screen. They don't want to go through that process of learning how to use a control system when, you know, just going in, hitting an on-off button works perfectly fine for them. But how much cost is an RV manufacturer willing to add to a unit to fix some of these problems if it makes their unit less desirable from a financial perspective to a buyer? So that's something they always have to keep in mind because it's such a critical part of the industry. How do we keep cost controllable in an area that keeps us competitive? And that's the key, competitive. Because if you see two identical floor plans from two separate manufacturers, one of them has all this really great engineered technology in that you may never see, but it's designed to make the RV more reliable, but you're never going to see it unless, you know, typically there would be a failure. But the other manufacturer doesn't do that, and one manufacturer is $10,000, $15,000, or $20,000 less expensive than the manufacturer that uses all that stuff. What RV are you going to likely buy if you don't know that that stuff is there, or if you don't trust that the manufacturer or the dealership is representing the product accurately? So these are all things that you have to keep in mind, and these are all things that are incredibly important, because for everybody who watches my video and goes out and buys an RV, there's 100,000 people who don't watch my videos and go out and buy an RV. So even though you all may know what to look for, and if I do an announcement that some manufacturer is improving all of this, well, they might get a bump in sales because you all are informed and you're doing your research and you're saying, wow, that's cool that they're doing it differently. It doesn't mean that that bump is enough to keep them afloat and for them to keep justifying using this stuff on all of their floor plans, considering the vast majority of people who buy an RV have probably never even heard of my YouTube channel. So that's kind of the key behind it. As many people as there are that use YouTube as a means to research this stuff and look for the advantages of one brand over another, oftentimes the vast majority of units that are being sold are being purchased by folks who have never been RVing before, and they haven't done a tremendous amount of research. They kind of, made the decision one day to get an RV, and a week later they have an RV because the dealership that's near their house happened to have one that they fell in love with simply by walking in, looking around, and seeing all the amenities that the specific unit had, but not being able to see or focus in on some of the areas that could have been done better. And that's the challenge in the RV industry. How do you build a unit that people want to buy with the things that they're looking for while still innovating and adding things that they'll never see that can improve safety, longevity, and reliability? Anyways, guys, I sure hope you enjoyed this video. It really was all over the place in terms of the topic, but I think it nailed the specific point I was trying to make. And that is a little bit more of the differences between vehicles and RVs, but more importantly, why there are some areas on vehicles that are focused on much more closely than you would see on an RV. And mainly it's because really in an RV, they don't need to focus on some of that stuff. But it's not a pass. There's definitely improvements that need to be made, and I think I called most of those out. Anyways, guys, I sure hope you enjoyed this video. If you haven't had a chance, please take a moment, subscribe to my channel, give me a thumbs up, and we will talk to you again very soon.